The other day we worked on tangent and cotangent. Today we're going to work on cosecant and secant. Cosecant is the reciprocal of sine. So just like the others, okay, that means it's a fraction. So if it's a fraction, you have a bottom number. And when you have a bottom number, you're not allowed to have 0 on the bottom. And since sine is on the bottom, cosecant does not exist when sine equals 0. And sine equals 0 at the following. At 0, pi, 2 pi, and so on. Sine will equal 0 at all the pi's. So all the whole numbers of pi's. So on a normal cosecant graph, you would have asymptotes whenever sine is 0. So here, and secant then. Secant is the reciprocal of cosine. That means secant doesn't exist when cosine equals 0. And cosine equals 0 at all the positive, negative half pi's. So these are the locations where you will find all your asymptotes. So, to graph them, this is the easiest way to do it. You won't actually graph cosecant and secant. What you will do is you will graph the sine and cosine version of it and then just simply flip it upside down. So, number 1, you're going to graph the sine or the cosine version. Number 2, you're going to find your asymptotes. And number 3, you're going to flip your answer. So down here at the bottom, we are going to start with secant, CSCX, which means we're really going to graph sine of x. And we've done that many times before. Do you remember what our key points are? Key points for sine are 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi, 0. So if we graph that, we get 0, here's our pi, and here's our 2 pi. So at a half a pi, we're at 1. At pi, we're back to 0. At 1.5 pi's, we're down to negative 1. And 2 pi, we're at 0 again. Now here's the deal when you graph these though. You don't want to draw solid lines. You just want to get an idea of what the shape looks like by graphing the sine answer. But your answer really isn't going to be the sine, so don't make it solid. Make it dashed instead. So that's the shape of a sine graph. A normal sine graph. So to get a cosecant graph, you're first going to have to find your asymptotes now. And asymptote happens wherever you cross at the x-axis. So that means we've got asymptotes in these locations right here. So you need to put your asymptotes in. These are the spots that your graph cannot cross, so you put them in. So that means your cosecant graph can only exist in between each of those two asymptotes. So all you have to do now is take the part that's actually inside the asymptote, which is the curved part of your sine graph, and flip them upside down. And when you flip them, you don't flip them over the x-axis, you flip them on themselves right at the peak. So if you flip it on the peak, it'll look like this. And the bottom one, like that. Keep in mind when you graph those, they need to keep the same shape. So if it's a fat little circle, make sure your circle's fat. If, for example, when you go to graph it, if it's a fat circle like this, so when you graph it, you're going to have a fat. If it's sharp, you're going to have a sharp turn. The turns on them have to be exact and precise. Okay? Now, that was done. Let's talk about an SEC graph. You get an SEC, a secant, when you actually graph a cosine. And the 5 key points for cosine are 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. So let's graph them and see what we get. At 0, we're at 1. Here's our pi and our 2 pi. 0, down to negative 1, back to 0, up to positive 1. And again, you just want to see the shape, so put dashed lines in. So then you find your asymptotes by simply filling in where the zeros are. Now look, sorry. You'll see 2 zeros here. You have a 0 here and a 0 here. So there's where your asymptotes are going to happen. So your answer then is the blue part, but flipped upside down. And since the first blue is only half a shape, you only make half a shape. The other one is down below. And then the last one is the one on top again. And again, it's only half a shape because I only want to see one cycle. The rest of it would be if I were to go into the next cycle. But we're not going into the next cycles. I only want one. So that's your graph and you're done. Let's do 2 examples. So again, to graph them, you first have to graph the sine and the cosine version of it. Sorry, we went the wrong way. We have to graph the sine and the cosine version, and then we can graph our secant and cosecant. So on the top one, because it's a secant, we're really going to graph 3 cosine of pi over x. And on the next one, it's supposed to be x plus pi over 2. So what we're really going to graph is 3, and because it's cosecant, that would be sine pi over 2x plus pi over 2. That's what we're going to graph on both of them. So let's see. You do the same method all the time. For graphing sine and cosine, we're back to what we were doing before. Step number 1, period. Period is 2 pi over b. So that would be 2 pi, and our b is what's with our x, which is pi. So the pi's cancel out, you got a period of 2. Then you need to know your increment spacings. Increments is always period over 4. So that's 2 divided by 4, so now you've got increments of 1/2. Then you need your phase shift. Phase shift is opposite c over b. And in this case, there is no c because there's nothing being added inside the parentheses. So there is none, which makes it nice. That means our start and our end is normal. So the last thing is your y values. What are you going to do to them? You're going to do whatever's on the outside. And the only thing I see on the outside is a 3. So we're going to take all of our y values and multiply them by 3. So we got to come up with our key points. 1, 2, 3, 4, 5. Okay? We start at 0, which is normal. We end at our period, which says 2. Our increment spacing is halves, so we get 1/2, 1, and 1.5. Now our y values, we have to multiply all of our y values by 3, and we're doing the cosine y values. Now remember what your cosine y values were? The first one was 1, 0, -1, 0, and 1 again. So when we take each one of those and multiply them by 3, we're going to get 3, 0, -3, 0, and 3. And we're ready to graph. Now remember when you graph this though, you want a dotted version, don't you? So we got to go all the way out to 2, all right, 1 and 2. So at 0, we're at 3. At 1/2, we're at 0. At 1, we're down to -3. At 1.5, we're back to 0. And at 2, we're back to 3 again. So my graph looks like this. That's the cosine version, but you really don't want the cosine version. You want the secant version. So that means you're going to have to find your asymptotes. Your asymptotes is where your graph crosses on the x-axis, and you got 2 of them. So you put your asymptotes in because you cannot cross those spots. This is where you cannot cross. Okay? And then your graph is simply taking those shapes and flipping them. And when you flip them at their peak. Don't flip them over the x-axis. So starts here and flips upward. The end one will start here and flip upward. And the bottom one will start at its peak and flip downward. Remember to keep the shape consistent. If it's a fat little shape, then this needs to be a fat shape. If it's a skinny shape, then you want a skinny shape. Okay? And that one's done. Let's graph the next one, sine. We need to do it all over again. We need period, increase. We got to go, every time you graph sine, cosine, you go through this step every time. Period first. That's 2 pi over what's with the x. In this case, it's pi over 2. That's a fraction. We don't divide fractions, so we got to multiply by the reciprocal. So that's going to be 2 pi times the reciprocal, which is 2 over pi. The pi's cancel each other out, so you got a period of 4 now. Increments. Increments is always period over 4. So 4 over 4, increment spacing of 1. Graph's going to go up by 1s. Phase shift. And we have a phase shift because we have a c. So we want negative c over b. Well, c in this case is pi over 2, and since it's opposite, it's going to be negative pi over 2 divided by b, which is also pi over 2. And anything over itself is 1, so my phase shift is equal to negative 1. Now what that does is, that's going to give us a new start and a new end. Whenever you have a phase shift, you will have a new start and a new ending. Normally we start at 0 and we end at the period, which is 4. But because of that phase shift, we have to add that in to both of them. So now our new start is negative 1 and our new ending is 3. And then we're going to take all of our y values, and the only thing we saw on the outside was a 3, so we're going to multiply them all by 3. Now if that was a negative on the outside, then you would multiply them all by a negative 3. So let's list out those key points. 1, 2, 3, 4, 5 key points. We start with a new start, which is negative 1, and our new ending, which we count to be 3. Our increments are still 1, so we're going to go up by 1, so negative 1 plus 1 would be 0, 1, 2, and of course we end at 3. Now, because we are graphing a sine function, you got to take all your y values for sine, don't you? So what are the y values for sine? They are 0, 1, 0, negative 1, and 0. And we got to multiply them all by 3. So that would be 0, 3, 0, negative 3, and 0. So let's graph it and see what we get. Here we go. Problem. Our graph has to go to negative 1. So that means we need to extend it backwards so that we have a negative 1. Because at negative 1, we're at 0. At 0, we're at 3. At 1, we're at 0. At 2, we're at negative 3. And at 3, we're back to 0 again. So our shape, remember, you're doing a dashed line, aren't you? Because this just gives us the shape that we want. That's not our answer. Because now we got to find our asymptotes, which are easy. They occur on the x-axis at 0. 1, 2, 3 of them. Put them in. You have to have your asymptotes to get credit. I want to see asymptotes. I want to see the 5 key points. I want to see the dashed sine graph or cosine graph. And then, of course, we want to see the flips, don't we? So now let's flip them all. So start at the peak and flip it. Start at the peak and flip it. And you're all done. That's how they work. So, again, period, increments, phase shift. If you have one, you need a start and an end. Get your Y values, get your key points, graph them using dashed lines, and then flip your answers. And you're done.